Hi everyone, this is Purnima Mahalingam. Today in this video lecture series, we are going to discuss about a speed control of DC drives. Come, let's go into the video. So what is DC drive? Here we can see in this topic, we are going to discuss about introduction to DC drive, separately excited DC motor, speed control methods, what are the control strategies of DC motors, and operating modes of DC motors. Come, let's go into the video. What is DC drive? It is an electrical drive employing DC motor as a drive movement. So dominating variable speed applications before introduction of power electronics converters. So it is still popular even after the power electronics converter. What is the advantages is a precious torques and speed control without sophisticated electronics. So main applications is it is in rolling mills, hoist, tractions, and cranes. These are the main applications of DC drives. And some limitations, we have high maintenance, that is commutators and pressures, and is an expensive, is speed limited, and sparking. So the commonly used DC motor, we know that separately excited and series and mostly used for tractions and applications. Here now coming to the separately excited DC motor, here the armature and field is excited separately, that is the armature and field of separate supplies, and we have an electromagnetic torque and back EMF equation, and the torque constant is equal to voltage constant. We have the voltage equation for both the armature and field supply. Now coming to excitation of DC motor, the motor is connected to the load. When the excitation torque, what happens is the torque equation, when the load torque, TL represents load torque and load inertia and viscous friction coefficient, B represents viscous frictions. Here it is excited with the load. Okay. Now coming to steady state condition, the time derivates to 0, and where the field voltage, and we have an armature that is back EMF EA, and the armature voltage where the formula, and finally we are replacing the EA by the value, and finally the torque equation. Finally the power, the developed power is equal to torque TE into omega. The developed torque is TE into omega. Now coming to the formula, what happens is this is the omega formula, omega equal to VA, and finally deriving this formula, VA equal to KV IF and minus RA KV IF. This is the speed, omega speed formula. Here, what are the slope? The speed is decreases. Here, the three possible methods for speed control. One is armature voltage method, next is armature resistance method, next is field current method. We can see the armature voltage, armature resistance, and field current by changing the resistance field. This is the flux. Okay. Now coming to speed control method of armature voltage method. Since it's an armature voltage control, what happens here? It record the armature voltage by keeping the armature voltage constants, the record variable DC supply. So with the record DC supply, what happens? The speed gets decreased. The speed gets decreases. Here we can the speed is decreased, but so by keeping the armature voltage constant. Now coming to here, the speed formula is there. Now, coming to our RA method, that is armature resistance control method. What happens by keeping the armature resistance constants? What happens? We have a variable speed. We can control the speed or above base speed or below base speed. Okay. Here, what are the slope equations are there? And we having the armature current, speed equations. Okay. This is the RA method. And now coming to last method of flux controlled method. Here the flux control, it is not possible. This method is not possible for permanent magnet motor and normally employs for speed above the speed. This method is for the speed which is above base speed. Here we can see that this is the base speed. The speed above the base speed, the flux control method is possible for the speed control, this speed control method. Here we can see the equations here. And coming to separately the exciting motor, where the base speed is equal to rated at VA, IF, and IA. Here we can see. Here the base speed is fixed. Example, 1500 is the base speed. So below base speed, the armature voltage control. We are going to apply the armature voltage method, and above base speed, we are going to apply the field control method. Here, these are based on the base speed. The base speed, because of the base speed is our example for 1500. If we decrease this, want to decrease the speed, we are going with the armature voltage method. And if we want to increase the speed, the base speed is above the base speed. If we want to decrease the base speed, we have to go for field control method. These are some of the exciting method of DC motor. Here we have an extra voltage control method based on torque and speed, etc. So these topics we can discuss in forthcoming classes. Okay, thank you so much.